Okay, this is part 2 of the chapter 7 review. For number 15, they want us to rationalize the denominator. So we're going to multiply the numerator and the denominator by the conjugate. So it's going to be 5 plus the square root of 5. The pattern they want us to see here is that we multiply by the conjugate. It's going to be that first term squared minus the second term squared. But even if you didn't see that and you followed the steps we've done for multiplying binomials, if you did 5 times 5 plus 5 times the square root of 5 minus the square root of 5 times 5 minus the square root of 5 times the square root of 5, we would get 25 plus 5 square root of 5 minus 5 square root of 5 minus the square root of 25. These terms are going to cancel, so it's 25 minus 5. So in my denominator, I'm going to get 20. In the numerator, it's 2 times the 5 to get 10 plus 2 square root 5. At this point, I would need to simplify by dividing or factoring out a 2 from both terms in the numerator and a 2 in the denominator, and writing this like 5 plus the square root of 5 divided by 10. I might end up having one with a complex number where you need to divide the complex number, but I'm going to post extra practice about that. For number 16, our first step is to isolate the radical when we have equations with the radical in it. I'm adding 3 on both sides. Square root of n plus 8 is going to be equal to 5. I'm going to square both sides of the equation. The square root of n plus 8 squared is going to be n plus 8 is equal to 25. When I subtract 8 on both sides, I get n equals 17. If I were to check the solution, 17 plus 8 minus 3 equals 2. The square root of 25 minus 3 equals 2. 5 minus 3 equals 2. 2 equals 2. Number 16 is a little easier. Number 17 is made a little bit more complicated with the variable outside, but I get 56 minus v equals v squared. So I would subtract 56 on both sides and add v to get 0 is equal to v squared plus v minus 56. At this point, if you have a quadratic that's set equal to 0, if you can, try to factor v plus and v minus. The only way to get two numbers that multiply to negative 56 that combine to or have a sum of the 1 here is if one of them is positive, the other one's negative. So it's going to be plus 8 minus 7. I set each of these factors equal to 0. So I get v equals negative 8 and v equals 7. They want us to go through and then substitute these values into the original equation. So if I had v equals negative 8, this would look like the square root of 56 minus negative 8 equals negative 8. Square root of 64 equals negative 8. They're going to say that this is not a solution. Although in the next chapter we'll talk about when we could take the square root and have it be look at both cases where it could be plus or positive or negative. But they will say that when v equals 7, I get the square root of 56 minus 7 equals 7. The square root of 49 equals 7. And this checks out. So our solution is v equals 7. I'll start with 19. For our complex numbers, when we're adding them, we're going to add the real terms. So this looks like negative 4 plus a negative 4. And then we got plus a negative 5i plus a negative I. So I get negative 8 minus 6I. And number 20, I would rewrite this as negative 2 minus 8I plus, and then a negative 4 plus I. Negative 2 plus negative 4 is negative 6. And negative 8 plus I is going to be minus 7I. In the same way we multiply the binomials, like x plus 3 times x plus 4, a lot of people are taught like that first, outer, inner, last, or double distributing. We want to do the same thing when we're multiplying complex numbers, but just remember that I squared is going to equal to negative 1. So I got 4 times 3, 4 times 2I, negative 4I times 3, negative 4I times 2I. So 12 plus 8I minus 12I minus 8I squared, or 12 minus 4I plus 8, or 20 minus 4I. All right, so that was the last problem we have on here. Again, if you have any questions, feel free to reach out. The test is on Monday, and good luck.